In this video, we're going to use what I call reverse engineering to factor quadratic expressions. So, especially for ones that we have to factor in the form ax squared plus bx plus c, we had some rather large numbers. I believe one of them was 294 or something like that. So it might take you a while to find two numbers that multiply to make the last term that add to make the middle. So let's see if we can speed things up a little bit using what I call reverse engineering. So reverse engineering just kind of works backwards from how you may have learned to solve quadratic equations in the past, where we're going to start with the solution and work our way back up, reverse our way back up to what the original problem would be. So we're going to essentially create the original problem from the answers. So you can use the x-intercepts of the graph of a quadratic expression to help you factor. So for instance, if we look at the graph of x squared plus 5x minus 6, it has x-intercepts at x equals negative 6 and x equals 1. So looking at that graph, here we have an x-intercept of negative 6 and an x-intercept of 1. Now we're going to use those values to help us factor. So if we start with our answers of x equals negative 6 and x equals 1, if we get each one of these equal to 0, by, in this one, adding 6 to both sides to get x plus 6 equals 0. And for x equals 1, we could subtract 1 from both sides and get x minus 1. If we look at x plus 6 and x minus 1, if we multiply that out, we get x squared plus 5x minus 6. So using that to help us with finding those factors, especially if you have larger numbers where it might be difficult. Or if you goof up on the positive and negatives and adding them together, this could give you a little bit of insurance to prevent that from happening. For ax squared plus bx plus c, we looked at a method that transforms it into x squared plus bx plus whatever a times c is. So get the transformation expression just like we did, and now it'll look like something from the last slide. Find those x-intercepts just like we saw, and then transform it back by dividing by the value of a and simplifying like we did in the last tutorial video. So let's say we have 3x squared minus 11x minus 4. Well, here's the graph, and yeah, we do get negative 0.333. We also get 4. And if you know that negative 0.333 is a decimal approximation for negative 1/3, everything's fine. However, we can transform this graph just like we did previously. So it would be x squared minus 11x minus 12. So let's look at the graph of x squared minus 11x minus 12. We'll just change these two values. And okay, I'm going to have to zoom out a little bit to see it. But here we have x equals negative 1, and here we have x equals 12. So looking at our x-intercepts at negative 1 and 12. So if we take and divide each of those by 3, we get x is negative 1/3 and x is 12 divided by 12 divided by 3 is 4. So at this step, we just transform them back and then move any remaining denominators in front of their variables, just like we did in the last video. So we'll get 3x equals negative 1, and we still have x equals 4. And now get each of these equal to 0. We can add 1 to both sides for the first one and subtract 4 from both sides from the second, and we get 3x plus 1 and x minus 4, which is how 3x squared minus 11x minus 4 factors as 3x plus 1 times x minus 4. So to reiterate, transform it just like we did in the last tutorial video, and then take the answers that you got and divide them by whatever this value of a is in front of the x squared. In this case, it was 3. So we get negative 1/3, and 12 divided by 3 is 4. And if you recall in the last video, any fractions we had remaining, we moved that denominator in front of our variables. So here, our variable just happens to be on the other side of the equation. We get 3x equals negative 1. Here we get still x equals 4, and then get this equal to 0 by adding 1. Get this one equal to 0 by subtracting 4. We get 3x plus 1 and x minus 4, which is how 3x squared minus 11x minus 4 factors. So hopefully this will help you, especially with the larger number ones. So it takes a lot of the guess and check and all that work out, which it is very comforting to know if you've ever had to spend a lot of time trying to find the values to make your quadratic factor, which can be a bit of a pain if you don't find them right away. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.